making, we started something new which called torsion. Torsion means twisting of the beam. For some reason, we can expect or we have torsion or twisting on the beam. Last time I told you probably we may neglect this torsion if T ultimate, which is the ultimate torsion moment, smaller than or equal this expression. By the way, phi in shear or torsion all the time 0.75 according to ACI. And F prime C, concrete strength, compressive strength of concrete, area CP, PCB, the area of the whole cross section, perimeter of the whole cross section. So area CP, B time H, PCB equal H plus B time 2, which is the perimeter. Lambda in this expression is 1 all the time because we are talking about normal weight concrete. This is the first check. Second check, you need to check also if this cross section is enough as concrete. I'm talking about concrete as a cross section is enough or not. So we need to check using this expression. If you have shear, include it. If you have torsion, include it. This expression must be smaller than or equal the right expression. You have to be sure, be careful about pH and area OH. This part is very important. I'm gonna draw a line at the center line of the stirrup. At the center line of the stirrup, at the center line of the stirrup, you know, your stirrups should have diameter. So at the center line exactly, I'm talking about this new section. The area of this inside section will be area OH. The perimeter for this section will be PH. To figure out the dimension of the new section, I can get x1 and y1 from this expression and this expression. We need only the width of the cross section minus 2 cover plus stirrup leg, 1 leg diameter, not area, diameter. And y1 equal the total, the overall depth, which is called h, minus 2 cover plus stirrup leg diameter. So I can figure out this expression and this expression to check. This one to check. You have to be sure this expression is valid or this relationship is valid. If this one not valid, that means the cross section as a concrete is not enough. You have to increase the dimension. Probably you increase the width or probably you increase the overall depth. Any questions so far? Any questions so far? According to ACI, the concrete cover is measured like this. It's a good question. You know, I will draw these details in more depth. Here is the stirrup. Your stirrup should have thickness, which is called diameter. This is the diameter. And here is the steel reinforcement. That's right. I'm not drawing just lines. No, I'm drawing with thickness. So this one is the stirrup. According to ACI, concrete cover means this clear distance from this edge to this edge. This is the cover. Actually, if you would like to reach this center line, you need to add something to this cover. So cover plus diameter of stirrup plus diameter, half diameter of rebars. These rebars. You got it? So, according to ACI, this clear cover probably for beams about 1.5 inch. So if you add this diameter of stirrup and this half diameter of rebars, you can reach this value around 2 inch to 2.5 inch. Okay, so cover means this clear distance. So I need to add half diameter from here and another half from this side. So the total will be diameter. Okay, okay. Then we need only to use this expression. Area T, area torsion, divide S equal T ultimate, which is applied torsion, ultimate applied torsion, divide 2 phi area note F yield cotan theta. What you mean by cotan theta? Theta is the angle for the stirrups. If your stirrups are vertical stirrups, your angle theta equals 0. Sometimes, I didn't see it in my life, actually. We bought probably your stirrups looks like this. Inclined stirrups with angle theta equal 30 or 45 or probably 60 sometimes. If you have angle, put it here. If your stirrups, vertical stirrup, your angle will be 0. Your angle will be 0, 99%, 95% most of the time. So, okay, that's fine. What is the value of area note? If you go back, we learned how to get area OH or note H. I'm talking about area note only. Area note will be 0.85 area OH. You remember area OH, the area of the inside section. After you draw at the center line of each stirrup leg. So 0.85 area OH. This area O. Pay 0.75. Okay, this side looks good. This right side looks good. What about this left side? S is the spacing between stirrups. Area T, be careful. Be careful. Area T, area of one leg of the stirrup. Please be careful. Anybody remember area V for shear? Do you remember area V? Area V was the area of all legs of the stirrup. If you have 4 legs, so the area of the whole 4 legs. But right now, I'm talking about area T, which is area of one leg only. Area of one leg of the stirrup. S is the spacing. So I give you expression for area T divide S. It's up to you. You can assume S to figure out the area T. You can assume area T to figure out the spacing. Let's do one example and see what's going on. For torsion, it's very easy to solve this problem in torsion. It's a piece of cake. Yeah, thank you, Oliver. Area V, number of legs, time area of one bar. But area T in torsion is only area of one leg. Anyway, we have a beam. This beam with width 16, overall depth 26. We have applied torsion, T ultimate, equal 50 kb foot. F prime C 4,000, F yield 60,000. The clear cover means this clear cover, 1.5 inch. The problem suggests to use number 4 as stirrups. Normal weight concrete, that means lambda equal 1. That makes sense. Please design closed stirrup to support this torsion. Do you remember? I told you before, stirrups for torsion are special stirrups. They must be closed stirrups for torsion. Okay, actually, to solve the problem in torsion, we need 3 steps. Can anybody let me know what will be the first step? Do you know? What should be the first step? Do you know? Thank you, Oliver. Yes, check. Probably 50 kb per foot is nothing. So we can neglect it and we are done. Probably. So, first step, we need to check if T ultimate can be neglected and stirrups are not required. Probably. So, we need to check T ultimate smaller than or equal phi lambda square root F prime C area CB square divide PCB. Guys, if you go back, area CB, the total area of the whole cross section, which is 16 times 26. That's it. So 16 times 26 equal 416. PCB, the perimeter of the whole cross section, will be 16 plus 26 times 2 will be 84. So the right hand side will be 0.75 times 1 square root F prime C, how much? 4,000. Area CP 416 square divide 84. What is the value of this expression? It will be 416 square divide 84 times 4,000 times 0.75. This value equal 97723.4 pound inch. Yeah, everything in pound, 4,000 psi pound, and everything in inch. So your final answer will be pound inch. On the left side, we have T ultimate 50 kb foot. So I need to convert from kb to pound, from foot to inch. So I need to multiply 50 times 12,000. This value will be 60. No, I'm sorry, 600,000. Yeah, 600,000 pound inch. So this one is 97,000. This one is 600,000. So I think this torsion is greater than. I cannot neglect this torsion. It's too much. I cannot neglect. If your torsion is smaller than or equal, that's fine. But it's greater than, no. We can not neglect torsion. Second step. Do you know what is the second step? We need to do another check. Probably this cross section, which is 16 times 26, is not enough. If the cross section is not enough, I cannot figure out how many stirrups or what is the spacing between stirrups, or I cannot design stirrups. I need to increase the cross section. So second step, we need to check of the concrete cross section. We have another expression, square root of V ultimate divide B web D square plus T ultimate PH divide 1.7 area OH square, all of them square, must be smaller than or equal phi VC divide B web depth plus 8 square root F prime C. That's right. However, to use this expression, I need to figure out what is the value of pH, what is the value of area OH. To figure these values, I need to go back to the cross section, draw center line and center line and center line and center line. So can you tell me what is the value of x1? This value of x1 equal 16 minus 2 cover, which is 1.5, plus, hey, plus, because I have a big bracket here. So plus, what is the diameter of number 4? Do you know how can I figure out the diameter? Yeah, if you go back to tables, for number 4, here is the diameter, 0.5. So the diameter is, I'm sorry, 0.5. Guys, if you go back here to this expression, x1 equal b minus 2 cover plus stirrup leg diameter. This term and this term inside this bracket, these brackets. Okay, so your final answer for x1 will be 16 minus 3 plus 0.5 equal 12.5. What is the value of y1? This one equal 26 minus 2 cover plus diameter. Your value will be 22.5. Any question? Any question? Thank you. So pH will be 12.5 plus 22.5 times 2. Area OH will be 12.5 times 22.5. 70, and this value will be 281.25. So this term is good. This term is good. The value of T ultimate, what was the value of T ultimate? 50. So 50 times 12,000. 12 for from feet to inch, 1,000 from cap to pound. This expression is 0. Do you have shear? We don't have shear force. We don't have shear force. What about the other side? This one is 0.75. Do you remember what was the value of VC? Go back to the shear. 2 P web depth square root of F prime C. That's right. If you go back, you will find this. So 2 time 16 time depth. What is the value of the depth? We can assume your depth here 2.5 from 26. It will be 23.5 square root for 4,000. So I can figure out the value of VC. B web is 16. This one is 23.5. 4,000. So I can check the right hand side. I can check the left side. I believe this expression will be smaller than this one. So concrete cross section will be good. Concrete is good. So second stage check, I need to check if the concrete cross section, the dimension of concrete are enough. Guys, to be more specific, I'm not talking about concrete as a material. I'm talking about concrete dimensions. To be more specific, concrete dimensions of the cross section are good. Any question, guys? Okay, looks good. Third and the last step. Very easy. Last step. Go ahead and use this equation, which is area T divide S equal T ultimate divide 2 phi area node F yield cotan theta. I believe your stirrups will be vertical stirrups. So cotan 0 is 1. Or this one can be neglected. I'm sorry. Your angle theta equal 90, not 0. Because if your angle is vertical, so the angle, if your stirrup is vertical, so the angle between the horizontal axis and the vertical stirrup will be 90. So your angle is 90, not 0. I'm sorry. Tan 0 is 1. Tan 90, I'm sorry, is 1. Anyway, so go ahead and put your numbers. T ultimate is 50 times 12,000. We need to make it in pound inch. 2 phi 0.75. What is the value of area node? Guys, from this step, I can figure out the value of area OH. Area node will be 0.85 area OH. So 0.85 from this value, 281.25. I can figure out the final value, 239. So 239. What is the value of F yield? Go back, 60,000. And this term will be neglected if your stirrups are vertical stirrups. So I can figure out the value of area T divide S. This one will be 0.0279. What is the size of the stirrups you are using? Based on the problem, we are using number 4. So what is the area of one leg? Area of one leg for number 4 point, how much? 0.2? Yeah, I believe. For number 4, the area is 0.2. That's right. So this term will be 0.2. Area of one leg. Remember, area of one leg. One leg. So the only unknown in this expression will be spacing. We can figure out the spacing. It will be 7.17 inch. To make it easy in the construction, it will be 7-inch spacing. Looks good. You're spacing 7. It's a good number. So guys, if you would like to solve problem under the effect of torsion, we have 3 steps. First step, you need to check if this torsion can be neglected or not. Second step, you need to check if this cross section is enough or not. Dimension. I'm talking about dimensions of the cross section. Third step, we need to figure out the spacing between stirrups. So finally, we will get a value for this expression. Area T, area of one leg, divide spacing, equal this number. So if you assume or if you have the area of one leg, I can figure out the spacing value.